In this
Tech Talk, we will be talking about indexing performance improvements made to the Gen 3 indexing services. Quick introduction to the Gen 3 indexing service. Gen 3 indexing service is a hash-based data indexing and tracking service providing 128-bit globally unique identifiers. A common problem is that physical data can move from one storage location to another, domain names change, or the data can exist in multiple locations at the same time. These changes lead to unreproducible research. Um, the Gen 3 indexing service serves as an abstraction layer over the physical data locations by providing a globally unique identifier um, for the underlying data. In the diagram, we can see that the physical location has moved from storage 1 to storage 2, and the ID no longer points to storage 1. We can also see that multiple IDs can be appointed to the same storage location. This abstraction helps data to be accessible even if data moves around. Users are also able to interact with this data through our Gen 3 indexing service using REST-like APIs. Looking at our stats, we can see that the data in the Data Commons framework has increased from 19 million in January 2022 to 52 million in August of 2022. And it's still growing at a fast rate. I will be showing some significant scaling changes we've made to the Data Commons framework services to make data available to researchers as soon as they've been released. Our standard indexing process looks something like this. We receive a manifest of records for indexing, we validate the format, and send it to our indexing job. The job then sends asynchronous API requests for each record to the Gen 3 indexing service to add record to our service database. This method of indexing was created for the scale of tens of thousands of records and is not appropriate for scales of millions. The problem with it is that it makes a single API request for each record in the indexing manifest. A single API request is sent over the network. The service needs to receive it and act on it and return a response to the client that sent it. This all happens in the time of milliseconds to seconds, which does not sound like a lot, but when we reach a scale of millions, these numbers add up and would take a significant amount of time. So we know that the bottleneck is the network overhead, and because that adds up, indexing for something like 25 million records would take months. Again, since we know the bottleneck is the network overhead, when making single API requests for each record that needs to be indexed, with our new indexing job, we talk directly to the database and bulk load the indexing manifest directly into the database tables. This means that there are no more single API calls for each records. We load everything into the tables in bulk. This initially unlocked 450 transactions per second to us, and after increasing the storage space of our AWS RDS instance to a terabyte, this unlocked 3,000 transactions per second. This means that the same 25 million records that we want to index now indexes in 4 to 5 hours. It's pretty good, but we can do better. This improvement is coming down the pipeline as of October of 2022. We will now look into the architecture of the database itself. Currently, Gen 3 indexing services uses AWS RDS. AWS RDS is basically like installing a database engine to an AWS EC2 instance. The only difference here being that RDS is already maintained by AWS. For more performance, we would like to switch from AWS RDS to AWS Aurora, while RDS runs the entire database in an EC2 instance. where each node handles both compute and storage. Aurora splits compute and storage into different pieces. This gives 2 times the throughput performance provided by Postgres, or 5 times the throughput provided by standard MySQL. From our test, we see 125,000 transactions per second compared to 3,000 in RDS. So we can now index 25 million records in under an hour. So just to point out some comparisons, standard indexing job uses RDS, so shared node for storage and compute with API overhead, versus no API overhead in AWS bulk load, versus split node for storage and compute with Aurora with no API overhead again. This gives us a result of 30 IOPS in standard indexing job versus 3,000 in RDS bulk load compared to 125,000 in Aurora. And in a real-world example, a standard indexing job would take us 25 million records. A standard indexing job of 25 million records would take us 1 to 2 months. The same file would take us 4 to 5 hours in RDS and less than an hour in Aurora. So these are some of the improvements we've had to make for some large-scale ingestion. For more information and questions, contact us at support@datacommons.io.